In first part, we discussed about the definitions and mathematical form and a few examples on Avogadro's law. In the next part, we will discuss in this lecture. Student, as I said to your people about the statement in the previous lecture, equal volume of gas contain equal number of particle and equal number of mole but different masses. Student, look, if we take three types of cylinder, one of them filled from hydrogen gas and one of them filled from oxygen gas, and the third one is filled from nitrogen gas. If we examine these cylinder, so as well, if we will find these three gas will occupy the same volume. If we look to the hydrogen gas, it occupied 22.4 decimeter cube volume. If we look to oxygen, it will also occupy 22.4 decimeter cube volume. If we look to nitrogen gas, it will also occupy 22.4 decimeter cube. So the volume are same. So the mean of that sentence is that if the same volume, then there will be same particle of each cases. Look at it. There will be also unit number, there will be, but the masses are different, students. If you look to the hydrogen mass, the hydrogen mass is 2 grams and the oxygen mass is 32, the nitrogen part 40 grams. So the mass are different. The mass will be different. In regard to same data, if we take any type of gas, they will occupy the same volume. It will contain the same particle, but the masses of the different gases will be different. Look at. There will be some question, sir. If the masses are different, so then volume why are same? Sir? Look at the volume are depend. The volume are depend on the number of mole. Volume doesn't depend upon mass. Just like Avogadro's number, if you take 2 gram, it will contain 6.023. If you take oxygen, but how Avogadro's depend upon mole is that like a volume is also depend upon the number of mole. Look at this is the mathematical form of Avogadro's law. K is the constant, V is the volume of the gas, and N number of mole of gas. Look at constant temperature and pressure. The ratio of volume with the number of mole will remain constant. What does it mean? If we don't change these two factors, the first one is temperature and the second one is pressure. If till we do not change these two factors, then the ratio of volume with the number of mole will remain constant. If we change any of these two factors, any one, then there will be volume to number of mole ratio will not constant. It will be variable. Look at here I have written 1 mole hydrogen gas can equal to 2 grams. We know that if you take any gas as 1 mole, it will occupy the 22.4 decimeter cube volume. So if someone asks from you, Sarji, if I take 1 gram of hydrogen gas, so then how many volume will occupied by 1 gram hydrogen? So then your answer will be S. There is a 2 gram is equal to 22.4 decimeter cube. So if we want to calculate for the 1 gram, so we will divide both sides by 2. So 1 gram will equal to, if we divide 22.4 decimeter by 2, we will get a result 11.2 decimeter cube. Means if we take 1 gram of hydrogen gas in cylinder, it will occupy 11.2 decimeter cube volume. Look at. If someone asks from you, we know that when we take 1 mole of oxygen gas, it is equal to 32 gram and it will occupy 22.4 decimeter cube volume. Here, if someone asks from you, for the 1 gram of oxygen, what will be the volume? Yeah, what will be the volume for 1 gram of oxygen molecule for the oxygen gas? So you can easily calculate. Both side will be divided by 32. Both side will be divided by 32. These 32 will cancel out with each other. So 1 gram is equal to 22.4 d cube divided by 32 grams. So S will be get result. So look at. So this is per 1 gram. This is per 1 gram. Look at. Look at. If someone asks from you such like question, if I take if I take 1 mole oxygen, it occupies 22.4 decimeter cube. So we know that 1 mole oxygen is equal to 32 gram. 32 gram is equal to 22.4 decimeter cube. So these are the talking about the gram. If you want to calculate the gram, so this formula will be used out. If someone asks from you, if 32 gram occupied 22.4 decimeter cube. So please, how many volume will occupy, how many gram of oxygen will contain in a single decimeter cube? Students, in 22.4 decimeter cube, there is a 32 gram oxygen. If someone asks from you, let's suppose how many how many gram of oxygen will contain in a single decimeter cube, so you can calculate just only divided both side by 22.4 decimeter cube. This side will also be divided by 22.4 decimeter cube. So this will cancel with each other. So 1 decimeter cube is equal to 32 gram divided by 22.4 decimeter cube. So this is formula. Students, this is the formula. So now I'm going to written formula. If there is demand from you about the gram, so what formula will be used? And if someone asks from you about the decimeter cube, so what formula we will use? So let's we come toward that side. Students, let's become. If the next example is, look at, again I'm writing that example that I have already mentioned. 1 mole oxygen contain 32 gram, 32 gram occupy 22.4 decimeter cube volume. Look at, 32 gram occupy 22.4 gram cube volume. If someone asks from you about 1 gram, so you will divide 32 gram divided by 32 grams. So x will cancel with each other. So per 1 gram is equal to 22.4 decimeter cube divided by 32 gram. So students, let's we can write from this equation the formula for the grams. So if demand from you about the mass to be calculated, so the formula will be used volume 22.4 decimeter cube divided by molar mass of that gas. Molar mass of that gas. For which gas you want to calculate, so that gas molar mass should be put here. Molar mass of that gas. So this formula will be used out to find out the volume, volume for a single gram of any gas. Students, again I'm telling you, if you want to calculate the volume per 1 gram of any gas, so this formula you should be noted in your mind. It will never be forget. If you forget this formula, then you will never be calculate the volume per 1 gram. So students, so noted that. Um, so first you should write volume as a 22.4 decimeter cube. 22.4 decimeter cube will be divided by mole mass of that gas, for which you want to calculate the volume of 1 gram. So this formula you should note it. The second one is per decimeter cube. Let's we write another equation from this way. Let's look at 32 gram contain 22.4 decimeter cube. If someone asks from you how many oxygen will contain in a single decimeter cube, so you will can divide 22.4 decimeter cube and that side will also be divided by 22.4 decimeter cube. So these two terms are similar, so they will be cancelled out with each other. So what will remain with us? So 1 decimeter cube is equal to 32 gram divided by 22.4 decimeter cube. This equation is reverse of just like this, of this one, because here is a 22.4 decimeter cube as in numerators, but here is a molar mass as a numerator and the volume as a denominators. So how can we calculate per single decimeter cube? If someone asks from you, one decimeter cube, one decimeter cube volume contain how many gas? So you can easily calculate. So formula will be this one decimeter cube per one decimeter cube. You can calculate the value from this equation that I'm going to write. So first of all, you will write molar mass, molar mass of gas divided by 22.4 decimeter cube. Student, this relation will be used to find out the number of grams in a single decimeter cube. So this formula and this formula, these two formulas are so important for from the exam point of view as well as from the indicate point of view. If someone asks from you about the centimeter cube, so how can we calculate the value per centimeter cube? Student, this value per decimeter cube. If someone asks from you about the centimeter cube, if someone said to you, uh, in a single centimeter cube, how many oxygen gas will contain? So then what you will be answered then? So then you will be confused, sir. We have never seen in your books such like formula. So now I'm telling you and listen carefully to it. Let's suppose 1 centimeter cube, 1 centimeter cube, for the 1 centimeter cube you can write molar mass of gas divided by 22.4 decimeter. You can also write as a 22.4 decimeter cube multiplied by 100,000. So it will become or 1 centimeter cube, it will be equal to molar mass of gas divided by 22,400 centimeter cube. Students, for this you can calculate. If you divide the molar mass of a gas and this value, so you will get the result in a 1 centimeter cube. So this is for 1 centimeter cube. If someone asks from you about the milligram, if someone asks from you this for the volume and for the milligram, someone asks from you, if I take 1 milligram oxygen, how many oxygen will occupied by it? So you can say at that time, for 1 milligram, you can write, you can write 22.4 dm cube divided by 22.4 decimeter cube. I'm so sorry. Molar mass of gas multiplied by 1000. So this formula will be used to find out the volume per a single milligram of any gas. If someone asks from you, please calculate. If I mention one MCQs, how many volume will be occupied by single milligram of oxygen? If someone asks from you, if I take 1 milligram oxygen, so then what will be volume per the 1 milligram of oxygen? So this above equation will be used out. 1 milligram is equal to 22.4 decimeter cube divided by molar mass of oxygen is of 32 multiplied by thousands. So this equation will be result will be get. If we calculate this value with each other, we will get the result for the 1 milligram of oxygen. So students, clear? And if someone asks from me about the sulfur trioxide, for 1 milligram of sulfur trioxide, you can also use at that equation 22.4 dm cube divided by 80 multiplied by thousands. So if you divide this value with each other, you will get the volume for 1 milligram of sulfur trioxide. Students, this is the Avogadro's law, and this is the part two. And I hope you will understand the lecture. If you have any doubt, any question about this topic, you can ask me anytime. Inshallah, I will be trying to give answer of your question to you. Please share this video with your friends and also subscribe my channels. At that, you will get the lecture at a time, and there will be no problem to your people. Thanks a lot. Give me allow till up to next lecture. We will meet in the next lecture. Allah Hafiz.